Hi kids, Miss Nichols here. Welcome to your first video recording of the semester. I hope you will use these kind of in lieu of class discussions and lectures. You're supposed to watch them on your own. You can look at the agenda and homework page to figure out which one you're supposed to be on. And as you watch them, I'd like you to take notes. So have your notebook out. You don't have to write down everything that I say or everything that's on the slides, but these are going to be a really important reference for you for your classwork and also for studying for your exam. So please do have a notebook out as you're watching these things. When you're done, I'd like you to go onto the website and click on the homework check-in button. Even though you're not being graded on this, it's an important way for me to keep track of how the class is doing on these, and so that I know who is keeping up with the work and who isn't. It's also going to be really important when exam time rolls around for you to check in to see, to make sure you've done everything that you need to do to make sure that you're ready to go for the unit. So please make sure you do that. Thanks. So hopefully you all have your notebook in front of you now. If you don't, pause this and go get it. When you get back with your notebook, I'd like you to set up the very first page in your notebook as follows, with 4 columns. The first column is labeled variable, and you may recall from math class that a variable is any number that doesn't have a set value. So if we talked about a number like your age, for example, that doesn't have the same value for everybody. And in fact, your own age is changing all the time. So that's a good example of a variable. There are other numbers called constants, like, for example, pi, if you learned about that, that has a value that never changes. It's the same for everybody in the world. So that would not be a variable. But most things that we talk about in this class are variables. The second column is symbol. And symbol is because physicists are lazy people. We don't like to write a lot of words in our notebooks or in our classwork, so we abbreviate our variables. Often symbol for a variable is the first letter of the word, but not always. We'll get those as we go along this year. The next column is for a short description of what the variable is, and the last column is a really important one called the units. Every time you write a number down in this class, it should have units after it, which are basically the way of telling me what range those values are in. So for example, if you just have the number 7, I don't know if you're talking about 7 inches or 7 pounds or 7 bags of dog poop, because you haven't explicitly told me what they are. So every number should have a units after it to make sure that everybody's on the same page about what we're talking about here. The first physics variable that we're going to talk about is one of the most fundamental, which is time. You're all probably asking yourselves, how long is this lecture going to take? Well, the only way to understand that is by starting off with an understanding of what time is. If I was doing this in front of you guys in class, I would probably start by asking you that question, what is time? And usually when I ask that question, someone will raise their hand and say, well, an hour. And I say, well, what's an hour? And they say, well, it's 60 minutes. And I say, okay, great. Well, what's a minute? And then they usually say a minute, 60 seconds. And we can keep on going into smaller and smaller pieces of time, but you see where we're running into a problem because it's really tough to define time except by using other pieces of time. Of course, it's really important that we standardize these variables so that everybody throughout the world knows what we're talking about when we talk about time. So scientists a long, long time ago tried to come up with a way to define a piece of time. And the first thing that they used was the Earth's rotation. You know, they started with a year and then they broke that into months. And every culture had its own calendar, as you've probably learned in history class, as a way to define how long things were. Now scientists know that none of these calendars are very accurate. We had to add that leap year every 4 years to account for the fact that, you know, it doesn't actually take quite 365, or it takes a little bit longer than 365 days for the Earth to rotate around the sun. So that leap year accommodates for it to some extent. But even that isn't perfect because it turns out that the Earth's orbit is changing. We're getting a little bit further away from the sun every year. So it's not really the best way to define time by using the Earth's orbit. After a lot of back and forth, scientists have finally arrived at a definition of time that does seem to be relatively consistent, that isn't changing. And it's not exactly a catchy definition. It's nothing that you're probably going to remember or be able to measure yourself. But the official definition of time, or the second, is how long it takes roughly, it takes a little atom of cesium which kind of jiggles back and forth to jiggle back and forth 9 billion times, give or take. So that's what a second is. I know, really catchy. Next time I ask you to do something for 10 minutes, I'm sure you're not going to pull out your atom of cesium and watch it jiggle. Instead, it's easiest just to have a sense of how long things take. So, you know, pull out your clock, try to count to 60 and see if it takes you a minute, and try to get a sense of how long a second is, because it's really useful to have your own internal clock and have a sense of how long time is. So let's add time to our variables page in our notebook. Of course, the variable is time. The symbol that we use to represent time is a lowercase t. Make sure you do a lowercase. We use uppercase for something else. Description is how long something takes. And there's lots of different units for time. As we mentioned earlier, you could use the second or the minute or the hour or the month or the eon or all sorts of crazy things. But typically in physics, we're usually using the second. That doesn't mean that all of your answers have to always be in seconds, but many of them will be. And if the unit isn't seconds, you have to be particularly careful to put units on your answer, because that's probably the one that I'm going to assume most of you are using. Our next important variable is distance, or you may have heard it called displacement. Those actually mean slightly different things, but we're not going to focus on that difference just now. We can use either of those words interchangeably. And distance was also a really challenging thing for scientists to define. They tried to use the size of the Earth itself and cut it into pieces and get smaller and smaller pieces until we finally arrived at something like a meter. But just like our orbit is changing, the size of the Earth is changing. It's actually squishing into a fat little donut as time passes. So not to mention erosion and things like that changing the shape of the surface of the Earth. So it turns out that the Earth is not the best way to define distance. The way they ended up defining distance was with the only object in the entire universe that travels at a set speed, and that is light in a vacuum. So all of our distance units are defined by how far a particle or a photon of light travels in a very, very small amount of time. Again, probably not something you're going to memorize. Instead, it's useful to have just a sense of how long things are. In this class, we use the metric system, which means no feet or inches. We're going to be using meters and centimeters. For me, I like to remember that my leg is basically exactly 1 meter tall. So if you're about 5'8" like I am, probably your leg is a good measure for a meter. If you're a lot taller or a lot shorter, you might have to find something else in your body to set as your standard. But a good thing to try to remember, so again, you can calibrate your own internal system of how long things are. So let's go ahead and fill in this first page of our notebook a little bit more with our distance variable. And the symbol for distance will be a lowercase d. Description of distance is how far apart two objects are. And as I mentioned earlier, we use the metric system here. The units that we will usually be using are the meter. And that can be abbreviated lowercase m if you want. There's one more unit that we're going to be adding to our notebook today, and that unit is mass. Mass is abbreviated with the symbol lowercase m, and the description of mass is how much stuff is inside of an object. Mass, just like time and distance, was really tough to define. In fact, it's the only variable that is still currently defined just with a single physical object. So there is a mass that exists that is the standard, the international standard for mass. And I actually am going to have an extra credit video that you can watch about how the evolution of that mass, if you are interested. It's kind of a well-produced NPR show called Radiolab, and I'll have that on the website. You'll notice that I'm careful not to mix up mass and weight. So the weight of an object is actually different. Weight depends on your location, right? If I go to outer space, for example, I don't have any weight, but I do have mass. There's still stuff in my body, I just don't weigh anything. So another way to picture what mass is how hard it is to shake an object. If you take a little tiny object and a big heavy object and you hold one in each hand and you shake them, the object with more mass is the one that's going to be harder to shake because it has more stuff in it. The units that we use are kilograms in this class, sometimes grams, but kilogram is abbreviated lowercase k, lowercase g, And a kilogram, you're probably all more familiar with pounds. Pounds, there's about 2.2 pounds in 1 kilogram, so it's a pretty large amount of weight. Humans would weigh somewhere between 50 and 70 or so kilograms. And if you like fruit, 1 pineapple is about equal to 1 kilogram. So it's a pretty large amount of mass. So almost done. Quick summary of what we've talked about. Every number in this class should have a variable or the symbol for that variable attached to it. Otherwise, I'm going to make some crazy assumptions about what it is, and you will almost certainly get the answer wrong. Almost every number should have a unit attached. I say almost because later on in the year, there's a few very special numbers that don't have units, but everything we've talked about does so far. And the last thing is, please don't forget to go to the website, www.5centphysics.weebly.com, and click on the homework check-in button to log the fact that you have watched this whole video. Thank you very much.